All right. Hello. Yeah, thanks for having me here today. I am Chandler. I am the growth strategist over at UMA. And today I want to talk to you about something that I've been thinking about for a while, and that is the idea of why Web3 needs a different design space for oracles. And want to just talk through some of the stuff that we've been doing at UMA and give you some inspiration from a development standpoint, and also kind of, yeah. And also, from developer standpoint on the hackathon, to have a kind of better ideas on what you can do with oracles, and kind of just, yeah, we're going to chat about a few things here. So my statement here is that oracles need to be flexible enough to create a generalized contracting past just kind of price feeds or data feeds. The standard modus operandi of how like oracles work these days is that prices and data are placed on chain, and there are some inefficiencies around this, which we'll kind of like walk through. So for like a general understanding of what an oracle is meant to do, the job of an oracle is really to bring some sort of data on chain. It can do this trustlessly, it can do this in a trusted way, and the most kind of interesting fact that we've seen with the evolution of oracles so far is that the general crypto space has moved away from trusted oracles, which is a good thing, but we kind of want to make sure that we have like a further improvement on this space, and we'll kind of walk through what we think a different oracle design can have on just the efficiency layer. And then kind of like the concept of having an oracle like live above a deterministic consensus layer is kind of where UMA will fit in. So if you think of a price feed oracle really is just a different version of a deterministic like consensus mechanism that really doesn't deviate too far from just what its one intended use is. And that's kind of where the inflexibility of the current price feed implementation of oracles kind of like stems from. And so if we kind of just assume like oracles bring data on chain, and if you look at like all the data that exists in the world, some data a little bit more valuable than others, right? And so really the concept of having like long tail data is something I'm going to like touch on in a little while, but the current like oracle space and what I tend to think of as like proof of work style oracles are the price feed style oracles. These kind of have a mechanism on-chain data being pushed regularly using some sort of decentralized consensus mechanism. These type of oracles has been the powerhouse of DeFi. So most of what we see in DeFi today are because of these price feed oracles, and they're super valuable and they're super important for maintaining like true systems. But these aren't really scalable for things outside of just DeFi. They're slightly inefficient on the gas level, and they're not inflexible enough to encompass things that everyone might not need, but they might actually want to have that sort of data for their own application-specific implementation. And so if you look at that, like I kind of think of just DeFi as a small segment of what the whole ecosystem can do. And so the real trick of what we want to try and do here at UMA is build out what that would look like past just prices. And so the sort of idea of like having this long tail of data being able to be brought on-chain in an efficient way is kind of what we're going to term the optimistic oracle. It's something that UMA's been working on for a while. It's similar in our concept from like a change from proof of work to proof of stake. And what we really are able to do is bring any verifiable state of the world on-chain through a network participation of proposers, disputers, and requesters. And this sort of like approach of having application-specific elements makes it a lot more flexible, and you can adapt to any sort of data methodology you want. So if you kind of think of it from a perspective of like what your application needs at any given point in time, you're able to bring that data on-chain with by using a methodology that you design yourself. And so you can kind of think of like a very wide space of where you can kind of create what you think you need for your specific application. And the other last most important thing, which I kind of want to make like known so that when you see further down in the presentation, is this idea of recourse, right? Price feed implementations typically have one flaw, is that you either accept that price and that's it. There's no way for you to dispute that. There's no way for you to kind of figure out if something went wrong. And so a lot of like people got wrecked in the ecosystem because in some instances like the oracle went down, was broken, or there was some version of like a hack that happened, and there was no mechanism for like a consensus layer to say, all right, something actually went wrong. Let's try and find a way to secure some funds. And so what we're thinking about here is how to like capture the whole generalized contracting layer. And that generalized contracting layer, I would argue, in my opinion, is a lot bigger than just simply price feed implementations. And so really the value capture that we want to try and provide to the whole ecosystem is to make sure that like whatever you think you can do with your kind of application and you need to bring data on chain, that's what we were trying to like focus a lot of our time on. So what really goes into one of these optimistic oracles, right? Our particular implementation has like 4 particular parts: a requester, a proposer, and a disputer network. We'll run into how that works in a bit. A dispute resolution process, a documented methodology of truth. This is where your application-specific elements come in, where you get to define how this data comes on chain, right? And then also some economic guarantees, which will also kind of run through as to what makes like the optimistic oracle kind of secure your data in some way, shape, or form. So the process of how it works really on this like disputer process is you can ask a question. That question can then be answered by someone. And so when you ask a question, you can say, all right, did this event happen? Yes or no? So you propose that the answer is yes. Somebody can either accept that. If it's accepted, it's assumed to be true. That's the optimistic sense, and that's the optimistic case. If not, somebody is able to dispute you, and this dispute can get boiled up to another resolution process, which we're calling our UMA's DVM. And that process of disputes is a bit more slow, a bit more thoughtful, and so you can kind of think of the dispute resolution process as a way of saying you can start off with the optimistic case, but in the event that something goes wrong, somebody inputs the wrong price, something gets hacked, you have this kind of layer to stop and go through some sort of like dispute resolution process. And what we're thinking here on this like dispute resolution process is where we can bring in recourse, where you can say something that's like outside of the standard process of building, the standard process of like resolving a price can, like, let's say it's a hack, let's say it's something like no one would have expected this to happen. Through a dispute resolution process, you can get to a consensus and say, actually, this is something that we never expected to happen, and resolve it to a point where the users of your protocol aren't actually affected by some sort of like data manipulation. And so one of the things that you might be thinking about, okay, we've got this process, this oracle, it's optimistic, it can resolve some prices. What are the things that have been built on it? So we've been around for, I think, roughly around a year. And what we've been quietly building with a couple of teams, a series of like projects that kind of like touch some of these points. So you can do prediction markets. It's a fairly easy one. Ask, did this event happen? Create a market around that. That's something that's actually that's live on the moment on UMA. The other one is DeFi insurance. If you kind of think about like the concept of insurance, it's a slow process of saying, all right, something happened. Does a payout need to happen or not? If you've defined insurance in a certain way, you can actually create a process where an oracle, in an optimistic case, can say, does this person deserve to be paid out, yes or no? If yes, then there is also a process where somebody can say, no, that needs to be disputed, right? The other one, which I think is like the least built out at the moment, is optimistic governance, which we kind of like been playing around with. Really cool. I'm personally excited about that. And then rewards as a service. So rewards as a service is something that we've actually built in-house at UMA. Hart Lambert, our co-founder, spoke about this on Tuesday. I'd highly recommend listening to that talk, where we're trying to find a far more efficient way to kind of create rewards as a service in a way that kind of like, if you think about most reward mechanisms, it's action-reaction based. And so you can reward somebody based on their actions optimistically, and then have it be disputed if that person is wrong. In that case, you can then build systems where you don't actually have to develop the logic for each of the reward mechanisms, like LP tokens, right? Deposit into an LP share, get LP tokens, stake those LP tokens, earn rewards. Those actions give me my rewards. What happens if I did that without ever having to code up that LP staking contract? That process of just having that logic live off chain and be enforced optimistically, I think will be quite a far more efficient like time saver for the space, if anyone can just kind of have like no code versions of rewards. KPI options, actually this is something that we're quite famous for. Community-based incentive tokens. if you ever want to chat about those, we're always happy for them. There's a lot of KPI options running out there in the world. And then the last one, which Umo used to be kind of known for, is these synthetic assets, where you can create derivative markets, you can create call option markets, you can kind of create these assets that kind of track anything. All right, but this is kind of cool in like one layer, but I actually think this optimistic oracle concept really scales well and efficiently in a layer 2 world, right? Most of Ethereum developers now are looking at a strategy on deploying on L2s. And so we've done the exact same, and we've kind of created something what we think is pretty cool, which is a cross. It's a L2 to L1 bridging solution that uses our oracle to verify that these bridging actions happened. So we kind of think, because of this process of not using AMMs and just using our oracle as this data validation method, a cross actually becomes a far cheaper and faster way for you to bridge assets from L1 to L2. So that's one way that you can kind of like use this oracle in an L2 world. But another way that I've been playing around with, and I'm going to go through an example in a second, but is in this cross-chain data validation. And this kind of needs to be explored. I'd be very interested in chatting to somebody at the hackathon who wants to build something along this line. But really, the cool part about data validation across chain is it makes it far more efficient for teams to have a strategy that is L2 compatible while maintaining a lot of their like infrastructure on L1. And if that's kind of confusing to you, let me run through an example. Like, very simply, I came up with this like very quickly, but kind of illustrates some of the potential that we can have here. So if you're a project, you're on L1, you're wanting to be on L2. I think almost every DAO or project in this room and in this event has that kind of problem or thought pattern at the moment. You have some core piece of your project that does not scale well across chains. One of the ones is the VE tokenomics. You stake your tokens, you earn some more rewards. Your rewards are based on how long you've been staked. Sometimes governance rights are very specific to like the chain that you're on. Umo's case, like voting rights on Umo very specifically has voting rights on Ethereum. And so how do you build an ability for your actions on L2 to have the same weight as what your like voting rights or your tokenomics on L1 have? And so in this specific implementation, you can kind of think of some of us using our oracle to verify that I have a bunch of these VE tokens on L1, but I'm doing my voting on L2. And you can do a cross-chain call to validate that that fact is true when doing that. And so we think like this kind of ties into some sort of optimistic governance process, but it also ties into like kind of a more efficient L2 scaling solution where you as a project can actually keep part of your infrastructure on L1 without ever having to go to L2. And that change in thought pattern, I think will be really efficient for most teams that really want to make sure that they capture like that they don't have to always lose the opportunity cost of having to transport from L1 to L2. And so this oracle kind of idea of cross-chain validation has two things. I can prove the state of something on L1 to L2, or I can enforce an outcome from L1 to L2. So you can kind of think of this as a two-way process of being able to say like, all right, this event happened on L2, I'm resolving it on L1, but then I'm also enforcing that resolution on L1 back to L2. And so voting kind of works well this way, dispute resolution kind of works this way, like holding your big bag on Ethereum while kind of doing your degen stuff on L2, kind of these sorts of things can play out. And I kind of find teams that really want to explore this, I'd be happy to chat about that. And so, why does Web3 need more oracles? Like, this is my thesis statement. This is what I want to make sure that at the end of this talk, you can at least have these core facts in your head. Optimistic oracles, you can still build a price feed. You can still build a price feed and introduce some level of recourse in your price feed. So the beneficial advantage here is that if something goes wrong, you have some sort of like fallback mechanism that you can play around with on your version of implementing price feeds. So it has that flexibility in itself. You can extend from just prices to capture the whole data, the whole data type range, and this can be on-chain data, off-chain data. This works well cross-chain. We've done it ourselves. Uma's dispute resolution process, wherever our optimistic oracle is on an L2, those disputes actually get resolved on L1, and we push that enforcement back to L2. And this works. and we've done it a couple times. And so the design space for teams to make use of this like capability, I think, has a lot more potential. And it's a lot more efficient. I kind of think that having a data being pushed to basically what is the world's most expensive database consistently is a really efficient method. And with this concept of having a proposals and dispute system, prices are only brought on chain at the time when it's needed. And so you can kind of think of this design pattern as like somewhat different, but very specifically a lot more efficient. Cool. So I'd like to highlight a few things that happened over this weekend and some just reading for anyone that's particularly interested in this topic. One of my colleagues, Chase Coleman, gave a more in-detail talk about what recourse and tail risk was. That was on Thursday at 2:40. I believe it's on the YouTube channel at the moment. A lot of the design around the oracle came from the Shelling Coin article from Vitalik a while back, and so we've borrowed kind of that design pattern from them. And then where we've kind of introduced the concept of our optimistic oracle, Hart Lambert wrote a post. It's on our Medium. I'm happy to share and tweet that out for anyone that's particularly interested in reading, like, you know, where this kind of came from. And then lastly, you can follow me on Twitter. I actually have a Pope if you want to claim that. And then there's a little bit of a game we're playing. If anyone here claims 5 Popes from the UMA team, you can win some cool prizes. So claim that one, get 1 out of 5. Meet us at the UMA booth to chat about some stuff, and then we can also give you some more Popes.